In this video, I will show you how to create an ensemble of models and explain why this is beneficial. We will also dive into our post-processing algorithm, the Ensemble Kalman Smoother, which I will refer to as EKS from now on. First, let's talk about model ensembling and why you might want to use it. An ensemble combines the predictions of multiple models to achieve better accuracy and robustness than any individual model. This is particularly useful when individual models make different types of mistakes. EKS is unique because it not only combines predictions from multiple models, but also incorporates a smoothing process to further refine the predictions. For more details, check out the Lightning Post paper by clicking the link in the show notes. Now I will demonstrate how to actually fit ensembles and run EKS in the app. To start, you need to have several trained models. These models can all be of the same type, but with different random seeds. For example, you could create an ensemble of several supervised networks, each of which uses a different random seed. Or, you can also create an ensemble composed of different model types. For example, you could create an ensemble that mixes supervised and semi-supervised models. I will be using the models we previously trained in the first project demo. Once you load the project, move to the Train Infer tab. Below the inference section, on the right-hand side, you will see the EKS section. First, select the models you want to use for your ensemble. I recommend using 3 to 5 models. Too few models, and you don't get the full benefits of ensembling. Too many models, and inference will take too long to be practical. I will select the first 2 models I have in my list for demonstration purposes. Now, let's give this ensemble a descriptive name. I'll call mine Super, Semi-Super, EKS, so I can remember this is an ensemble of my supervised and semi-supervised models. Click Create Ensemble. The process should only take a couple seconds. You will see an ensemble created message when it's done. Congratulations, you have now created a new ensemble that you can use with your data. Next, I'll show you how to run inference on a video with this new ensemble. In the inference section, I will select the newly created ensemble. If you do not see your ensemble in the list of available models, just click on the Rerun button in the top right corner of the tab. I will then choose to run inference on a previously uploaded video and select Test Vid from the list. I will also select to save a fully labeled video. Remember that your studio should be connected to a GPU machine for running inference. Now, let's run the inference. Once you click the button, you'll see a series of progress bars appear, one for each video and ensemble member. If you have already run inference with one or more of the models in the ensemble, the app will skip inference for those models. After inference has been run with all models in the ensemble, the EKS post-processor will run automatically to combine the ensemble predictions, which will have its own progress bar. The EKS results will be saved in the models directory under the unique ensemble name you provided. Great! Now that we have run inference, let's compare the EKS results to one of our base models. To do this, let's move to the Video Diagnostics tab. I'll compare the supervised model to the EKS. Select the test vid or the video that you ran inference on. First, let's look at the temporal norm of those models. You'll see that in general, the EKS model produces smoother results. Now, let's look at the traces of one of the key points to see the difference between the models. I will select the tail-top key point. Immediately, we can see that the EKS traces are smoother and contain fewer glitches. Feel free to play around with other videos and key points as well. If you checked one of the boxes to create a labeled video during inference with this ensemble, you can also view the video overlaid with the EKS predictions in the Video Player tab, as well as download the prediction CSV file there. Now that we have seen how to use EKS and how it works, you can play around and try different combinations of models to see what works best for your data. Thank you for watching. If you found this video helpful, please like, subscribe, and leave a comment below. See you in the next tutorial.